Welcome to the Deep Dive. Today we're tackling something called empowering education via MICT EDU AI V2.
It sounds a bit dense, maybe?
It can seem that way at first glance.
But think of it as like unlocking a new perspective on learning, especially now with AI becoming such a huge factor.
Exactly. And for you, the learner, our aim here is pretty straightforward. We've gone through the document outlining this MICT EDU AI V2 framework.
Yeah.
It's from John Reagan at Board Brains Consortium with some AI input too, like from Gemini.
Right.
And we want to pull out the really key insights for you. Cut through the jargon, get to the aha moments without you feeling totally overwhelmed.
So our mission today is basically, let's figure out what this MICT or MICT-QC, as it's sometimes called, actually is. Why is it popping up in education discussions now, especially, with AI changing things?
Mm-hmm.
And maybe uncover some, surprising ideas about how we actually learn best. Okay, so let's start at the foundation. What is MICT-HQC?
Okay, so MICT itself stands for Mobius Inspired Cyclical Transformation.
Mobius, like the strip. Yeah, exactly like the Mobius strip, that loop with only one side. The cyclical part in MICT suggests learning is kind of like that. It's a journey that loops back but also moves forward, always evolving, deepening your understanding, maybe in ways you didn't expect. It's like a continuous improvement cycle.
A learning loop, but with a twist. I like that. Okay, and the HQC part, Human Quantum Cognition. Now, the document stresses this isn't saying our brains are quantum computers.
Right. Very important distinction. No tiny quantum computers in our skulls.
So why quantum? What's the idea there?
HQC uses concepts from quantum physics, but really as a powerful metaphor. It's a way to better describe those aspects of human thinking that are, well, a bit fuzzy, less predictable, things that classical models sometimes struggle with.
Oh, okay.
It's about capturing the uncertainty, the fluidity, the way context changes everything, how we really think, not just neat logical steps.
So less about literal physics, more about using those quantum ideas as a lens to see thinking differently. What kind of insights does that lens give us?
It highlights several key things. First, probabilistic thinking. We're almost never 100% certain. We deal in likelihoods, degrees of belief. Yeah, that feels true. Embracing that uncertainty, exploring possibilities, that becomes a learning strength. Then there's context dependence. Hugely important. What you already know, where you are, who you're with, it all shapes how you understand something new. Right. Also, continuous transitions. Understanding doesn't just flick on like a light switch. It often grows gradually, it shifts, it refines, it's more like a dimmer.
Okay.
And finally, something called hierarchical thinking, or the infinity ladder.
Right.
We think at different zoom levels, very specific details, broad concepts, and we move between them.
Probabilities, context, gradual shifts, different levels of thinking. I can see how older models might miss that fluidity. So why is this MICT HQC approach gaining traction now? What makes it relevant for education today, especially with AI joining the party?
Well, if you put it all together, MICT HQC gives us a blueprint, sort of, for designing learning that feels more, human, more aligned with how our minds actually seem to operate.
So potentially more effective learning.
More engaging.
Exactly. And beyond just effectiveness, it naturally encourages those skills we keep hearing about: critical thinking, complex problem solving, creativity, because it pushes you to deal with ambiguity, multiple viewpoints, complexity.
That makes sense. If learning isn't just step by step, teaching shouldn't be either. What else?
It also really supports personalized learning, because it inherently acknowledges everyone comes in with different background knowledge, different ways of processing probabilities based on their experiences. It helps educators understand teaching and learning on a deeper level too. And crucially, when it comes to AI, it provides a framework for weaving AI in thoughtfully.
Right.
AI becomes a tool within that human learning cycle. It supports it, augments it, but doesn't replace the human interaction or that deep, sometimes messy process of real understanding. AI is a partner, not a replacement.
AI is the helpful assistant, maybe the superpowered intern, not the teacher.
Got it.
Now, you mentioned MICT as a cycle. What are the stages? Right, the MICT cycle. It's described with 4 key stages: mapping, iteration, checking, and transformation.
Okay.
Think of it as this continuous loop where each stage flows into the next, and the whole process refine understanding as you go around.
Mapping. Sounds like step 1, getting the lay of the land.
Precisely. Mapping is all about understanding the starting point. Who are the learners? What do they already know or think they know? What are their learning styles, strengths, weaknesses? What motivates them? Even their social emotional state.
Okay, so knowing the students, what else?
It's also mapping the learning environment. The physical classroom, sure, but also the social dynamics, the cultural context, what resources, books, tech, time are actually available. And of course, the curriculum itself, the learning objectives. What are we actually trying to achieve here?
Right.
Essentially, it answers that big question, where are we starting from?
So if I were teaching, I don't know, the American Revolution, mapping would be finding out what kids remember from last year, figuring out who learns best by reading versus debating, checking if we have access to primary sources online.
Exactly, and clearly defining what understanding the revolution actually means for this lesson or unit. What should they know? What skills should they develop?
Yeah.
The document stresses that without this clear map, trying to navigate the rest of the cycle is, well, much, much harder. You're kind of flying blind.
Okay, map in hand. What's next in the cycle? Iteration.
Iteration, yeah. This is the active part. This is where the learning gets dynamic. Experimentation, exploration, trying things out, getting your hands dirty, so to speak.
So this is where the action is. Group work, discussions, maybe simulations, debates.
Absolutely. All those active learning strategies, it's about giving learners opportunities to really grapple with the material, to build understanding through doing, through experience. The document mentions things like formative assessments during the process, not just at the end. Peer feedback, chances to revise work based on that feedback, problem-based learning where you tackle a real issue, even activities that explicitly build a growth mindset.
So for that American Revolution example, iteration might be staging a debate between loyalists and patriots. Or maybe students working in groups to analyze letters written during that time.
Perfect examples. Or maybe using a simulation to understand the challenges of commanding troops. It's the doing, the active engagement, not just sitting and listening. That's key here. It's active.
Okay, active exploration, trying things out, then what? We've done stuff, now we need to check it.
Exactly. Checking is the next stage. This is where you pause, you analyze the evidence, what did we actually learn during that iteration phase, and you reflect.
So assessment, but maybe not just the big final exam.
Definitely not just that. The framework emphasizes frequent, low-stakes formative assessments, quick quizzes, exit tickets, asking students to explain a concept in their own words, things that give both the learner and the teacher a snapshot of current understanding. It's also about providing really constructive feedback, not just a grade, but guidance on how to improve, encouraging self-reflection. What do I understand well? What's still confusing? Using peer review effectively, maybe using rubrics so everyone knows what success looks like, even looking at assessment data to spot patterns.
So after that patriot-loyalist debate, maybe students write a short reflection on how their perspective shifted, or they get specific feedback from peers on the evidence they use.
Precisely. It's about taking stock. Where are we now in our understanding? What needs more work? This checking stage is vital because it informs what happens next. Do we need another round of iteration on a specific point? Or are we ready to move towards transformation?
Okay, which brings us to the last stage, transformation. Sounds significant.
It is. Transformation is about consolidating that learning, making it deeper, more robust, and crucially, being able to apply it. Taking the knowledge and skills from the classroom and connecting them to new situations, to the wider world.
So moving beyond just knowing facts.
Absolutely. It's about internalizing the learning so it changes how you think, how you see things, what you can do. It's about developing skills and perspectives that are useful for life, not just for the test.
What does that look like in practice?
Well, reflection activities are key here too, but maybe looking at the whole learning journey. How has my understanding truly changed? How can I use this? Application activities where students tackle new problems using what they've learned. Project-based learning often culminates in this stage, creating something, solving a real problem. It can also involve setting goals for future learning and, importantly, celebrating the growth and the learning that's happened, acknowledging the progress.
So for the revolution example, transformation might be students researching a modern independence movement and comparing its causes and strategies to the American Revolution. Or maybe creating a project proposing a solution to a local community issue, drawing parallels to the principles debated back then.
Exactly. It's about integrating the learning and using it productively. The document really emphasizes this isn't just about knowledge acquisition, it's about developing confidence, changing perspectives, building skills for the future.
Okay, mapping iteration, checking, transformation, and then the cycle begins again, maybe on a new topic or revisiting the same one at a deeper level. Now, the framework also talks about a dimensional aspect of learning. That's not like
Brie.
3D glasses, right?
No, not physical dimensions. These dimensions are about levels of understanding. Think complexity, abstraction, how interconnected ideas become in your mind.
Okay, so going from simple to complex.
Kind of. It's like moving from knowing a single isolated fact to seeing how it connects to a whole network of ideas.
How does the document break that down?
It talks about 1D or one-dimensional learning,
Yep.
just grasping a basic piece of information, like a vocabulary definition. Linear.
Okay.
Then 2D, two-dimensional. Understanding a relationship between two concepts. Cause and effect, compare and contrast. 3D, three-dimensional learning. Seeing a more holistic picture, how multiple factors interact within a system, like understanding an ecosystem or the factors leading to a historical event.
I see.
And then higher dimensions, even greater complexity and abstraction. Seeing connections between different systems or disciplines, like how physics principles apply in biology or how economic factors influence political decisions.
That's a really useful way to think about depth of understanding. So learning complex things involves moving through these dimensions.
Ideally, yes. You start with the basics, the 1D facts, then build connections 2D, then see the larger systems, 3D, and eventually grasp those really high-level abstract connections.
And how does this dimensional idea connect back to the MICT cycle?
It touches all stages. Mapping helps identify which dimensions are relevant for a topic. Iteration might involve activities designed to move learners between dimensions, maybe from recalling facts to analyzing relationships. Checking needs to assess understanding at different dimensional levels. And transformation often involves achieving a higher dimensional perspective, seeing the bigger picture.
It's all interconnected. Okay, let's circle back to HQC, Human Quantum Cognition. We know it's metaphorical. How do those specific quantum-inspired ideas, probabilistic thinking, context, continuous transitions, hierarchy, actually play out in an educational setting? What's the practical takeaway?
Well, they really shed light on the process of learning. Take probabilistic thinking. It reminds us understanding isn't usually yes-no. It's often partial, evolving. So education should encourage exploring different viewpoints, evaluating evidence, understanding degrees of certainty, not just hunting for the single right answer.
Okay, less black and white.
Right. Context dependence. It means learning thrives in rich, varied environments. We need to connect new ideas to learners' existing knowledge, their personal context. The environment itself matters.
Makes sense.
Continuous transitions tells us learning is gradual. We need patience. We need to revisit ideas, allow time for understanding to deepen. People learn at different paces. And hierarchical thinking, the infinity ladder, means we need to help learners navigate those levels. Connect the dots between details in the big picture, synthesize information. The document also mentions superposition, metaphorically speaking.
Superposition.
Yeah, like holding multiple possibilities or interpretations in mind at once. Encouraging that kind of thinking helps with complex problems, ambiguity, creativity, asking open-ended questions.
And embrace uncertainty. Value context. Be patient. Connect levels. Stay open to multiple ideas. That sounds like a richer way to learn. Now, the big question, AI. It's in the name MICT EDU AI. How does AI fit into this HQC-influenced cyclical view of learning?
The framework sees AI as a potentially powerful partner, a tool, but a tool used to amplify human capabilities, human learning, not to replace the human element.
The superpowered assistant again. What kinds of jobs could this assistant do?
Lots of possibilities. The document suggests AI could help personalize learning paths, adapting to individual student needs and speeds. It could act as an intelligent tutor, offering targeted feedback or explanations. It could generate diverse learning materials, readings, practice questions, maybe even simulations. AI could also analyze learning data to help teachers see where students might need extra support. And it could automate some routine tasks, freeing up educators for more meaningful interaction with students.
Okay, that sounds genuinely helpful, letting teachers focus on the human side. How does the MICT cycle itself change when AI is part of the mix, from the student's view?
AI could potentially enhance each stage for the learner. In mapping, maybe AI helps gather initial information or provides background context quickly.
Right.
During iteration, AI could power interactive simulations, provide practice environments, maybe even act as a brainstorming partner.
Interesting.
For checking, AI could offer instant feedback on certain kinds of tasks, suggest alternative approaches if a student is stuck, maybe help them identify patterns in their own work. And in transformation, AI might help synthesize vast amounts of information for a project, or perhaps model complex systems to explore real-world applications.
So AI isn't just a content delivery system, it's woven into the process of iterating, checking, transforming. What about for the teacher? How does MICT HQC guide them in using AI effectively?
That's a key part. The document actually applies the MICT cycle to the process of AI integration itself for educators.
Meta MICT.
Kind of. So mapping for the educator means understanding the AI tools. What can they really do? How do they align with learning goals? Are my students ready for this tool? What are the ethical considerations?
All right, groundwork first.
Then iteration, designing lessons that actually integrate the AI effectively, maybe piloting a tool with a small group first, training students on responsible use, how to use it, when not to use it, how to evaluate its output.
Critical skills there.
Checking, this is crucial, evaluating, is this AI tool actually improving learning? How do we assess student work when AI was involved? How to handle challenges like potential over-reliance or, academic integrity issues?
Yeah, big questions.
And finally, transformation for the educator. Refining their strategies based on what they learned during checking. Building students' critical AI literacy, understanding how these tools work, their biases, their limits, and promoting this idea of lifelong learning with AI as part of the toolkit.
So it's a continuous cycle for the teacher too. Map, try, check, refine how they use AI. It emphasizes that thoughtful, principled integration is key. It's not just about grabbing the newest shiny AI toy.
Exactly. It has to be driven by pedagogy, by principles like MICT HQC to actually add value.
Okay, this framework sounds robust. Can it really work across the board, different subjects in school?
The document argues yes, absolutely. It provides examples or suggests applications across math, science, language arts, history, foreign languages, the arts, career and technical education, CTE, health, computer science, even cross-curricular projects.
Could you give us just a quick feel for maybe one or two? How might it look in, say, science versus computer science?
Sure. In science, inquiry-based learning fits MICT really well. Mapping the existing knowledge, iteration through experiments, maybe AI-powered virtual labs. Checking data, AI could help analyze or suggest interpretations. Transformation by applying concepts to new problems. HQC's probabilistic thinking fits right in with experimental uncertainty. Dimensional learning is obvious facts to relationships to complex systems.
Okay. And computer science?
Similar logic. Mapping. Understanding the problem, maybe breaking it down. Iteration. Coding. Debugging, testing. AI could assist here, maybe suggesting code snippets or helping find bugs. Checking, analyzing if the code works, meets requirements. AI could help automate some testing. Transformation, refining the code, optimizing it, maybe applying the programming concepts to a larger project. HQC's probabilistic thinking applies to debugging strategies. Dimensional learning goes from basic syntax to complex algorithm design and system architecture.
That gives a clearer picture of its flexibility. Now, you mentioned growth mindset earlier. How does MICT HQC, especially with AI involved, help foster that belief that you can improve?
There's a really strong link. A growth mindset believing effort leads to improvement fits perfectly with MICT's iterative nature. You try, you check, you learn, you iterate again. It's all about process and improvement.
Right.
The document suggests strategies like focus praise on the process, the effort, the strategies used especially when using AI, not just the final output or seeming talent. Reframe mistakes, including errors made by or with AI as learning opportunities. What went wrong? How can we fix it? What does this tell us about the AI's limits? Provide specific, constructive feedback, maybe focusing on how the AI was used effectively or ineffectively. Use growth-oriented language. Teach students explicitly about neuroplasticity, how their brains can change, and about AI capabilities and limitations. Model that growth mindset yourself as an educator, and encourage reflection on the learning process itself, including interactions with AI, using MICT on your AI use, basically.
So creating a culture where trying, stumbling, learning from it with or without AI is the norm. It's about the journey. Okay, one last area. Collaboration and communication. Still vital skills, right? How does this framework address them, especially when AI tools might tempt students to work alone?
Absolutely vital. MICT inherently supports collaboration through things like group work and iteration or peer feedback and checking. But you're right, AI adds a new layer. It could potentially enhance collaboration. Maybe an AI tool helps a group organize ideas, but it could also hinder it if not managed well.
So how do we guide it?
The document suggests being intentional. Clearly define roles in group work. What are the humans doing? What is the AI assisting with? Set clear guidelines for how AI can be used collaboratively in a team setting. And crucially, teach students to critically evaluate AI contributions just as they would evaluate information from any other source. Don't just blindly accept what the AI suggests.
So structure the collaboration to ensure human-to-human interaction and critical thinking remain central, even if AI is playing a supporting role.
Precisely. The goal is still to build those core human skills of communication, teamwork, critical discussion, negotiation. AI should support that, not undermine it.
Well, this has been incredibly insightful. It really feels like MICT EDU AI V2 offers a comprehensive and, importantly, a human-centric way to navigate education as AI becomes more prevalent.
I think that's a good way to put it. It emphasizes that learning is a cycle, an ongoing process. It acknowledges the nuances, the probabilities, the context dependence of how we actually think. And it provides a structure for bringing AI into the picture thoughtfully, as a tool to enhance learning, not dominate it.
So for you, the listener, hopefully this deep dive has given you a solid handle on these ideas, maybe a new lens to look at your own learning or how technology might play a role.
Yeah, and maybe a final thought to leave you with, thinking about those dimensions of learning we discussed. How could consciously thinking about the level of complexity, am I just recalling facts, 1D? Am I connecting ideas, 2D? Am I seeing the whole system, 3D? How could that change your approach next time you tackle something new? What dimension are you usually operating in? And how could you push yourself to explore a higher, more interconnected dimension of understanding?
That's a great question to ponder. The MICT framework and AI in education are obviously huge, evolving topics. We definitely encourage you to explore further, maybe check out the Board Brains Consortium site mentioned in the source material, or just reflect on your own learning through this MICT HQC lens.
There's certainly a lot more to think about.
Indeed. Thank you for taking this deep dive with us today.